Welcome to GER Hub Mathematics and Statistics lessons, and Merry Christmas to all of you out there. Thank you for your subscriptions to the channel. Thank you for your likes and comments to our videos. Thank you for your shares of our videos. We are very grateful from the decks of GER Hub. If you haven't subscribed to the channel yet, please click the subscription button below and make sure you turn on your notification bell. Thank you very much for your support to the channel. We are grateful. So, in today's video, I'm going to be talking about probability, and I shall start with answering the question, what is the probability of an event? For us to answer the question, what is the probability of an event, we must start with answering the question, what are random experiments? So we must discuss random experiments, okay? So how do we begin with discussing random experiments? We are going to start with the definition of what random experiments are. Now, random experiments are experiments whose outcomes cannot be predicted in advance. So any experiment whose outcome you cannot predict in advance is called a random experiment. And this makes random experiments different from the experiments you perform in chemistry, some of the experiments you perform in physics, some of the experiments you perform in biology, or even in engineering or any other field of academics, okay? So random experiments are different from such experiments simply because you can tell the outcome or the result of such experiments you perform in other fields in advance. If you can tell the outcome of an experiment even before the experiment is carried out, then it means that that experiment was not random after all. In probability, our concern is with experiments that are random. And I'm going to give you examples of such experiments, okay? So let us consider examples of random experiments. So examples of random experiments are one, tossing a fair coin. So when you toss a fair coin, you are inevitably performing a random experiment, okay? When you toss a fair die, you are also performing a random experiment. When you shuffle a card deck, okay? When you shuffle a card deck, so shuffling a card deck is also a random experiment. Now I'm going to explain why these experiments I'm writing out are all random experiments, okay? So let's see. Now the last one I'm going to write here is aiming a target. So these are all examples of random experiments. Why are they examples of random experiments? Now let's consider, to start with, the activity of tossing a fair coin, okay? Now, tossing a fair coin is a random experiment because before the coin lands, in every trial of that activity or in every trial of that experiment, before the coin lands, you cannot tell what side will show up, okay? So if you could tell what side will show up after tossing the coin and before it lands, then that experiment is not random. But because you cannot tell until the coin lands after tossing it what side will show up, that activity for several trials of it is random, okay? Now, the same thing applies to a fair die. Tossing a fair die is a random experiment because tossing a fair die requires you to toss the die and wait for the result, what side will show. If a 1 shows, it shows based on chance. It does not show based on certainty. So we cannot tell before the tossing stops what side will show on the die. Is it a 1, a 2, a 3, a 4, a 5, or a 6? So because we cannot tell what side will show up, we cannot call such an experiment a regular experiment. It is a random experiment. The same thing applies to shuffling a card deck. When a card deck is shuffled, you cannot tell what card you'll pick until you pick that card. So it makes it a random experiment. The same thing applies to aiming a target. In football, shots are made at the goalpost, and you cannot tell whether or not before the shot is kicked, whether it will hit the target or miss the target. That is, whether it will be a goal or not be a goal. So these experiments are all random experiments. Tossing a fair coin, shuffling a card deck, tossing a fair die, aiming a target. These are all examples of random experiments. Now, I must clarify before we proceed what we mean rather, with what the terminology outcome means. So, outcome means the result of an experiment. The result of an experiment. So in this case, random experiment. So when you hear me say outcome in this video, I'm actually referring to the result of an experiment. In this case, random experiments. Okay. So let's see. Another terminology I would like to clarify is the word fair. So you've heard me use this word fair coin, fair die. I've used those words as adjectives qualifying coin and die. So now let's explain the word fair. When is a coin fair? Why do we say a fair coin instead of saying just a coin? Please, you must take note of this. What we refer to as a fair coin is a coin that can land on either of its base, okay? A coin that can land on either of its base is called a fair coin in our discussion on probability. Now take note of one thing. Any of the coin's base can be called a head or a tail. Either of the base can be called a tail or a head. But you must take note of these. What we call the head is the surface of interest. So if I call this my head, the head of this coin, then it means that I'm only calling it the head because it is the surface of interest. Okay? So if it wasn't the surface of interest, I would not call it my head. Now I'm only calling it my head because it is the surface of interest, and automatically once you pick this side to be the surface of interest, hence calling it your head, automatically the other side becomes your tail. Okay, so what we call a fair coin is a coin that can land either on its head or on its tail. Now that eliminates the possibility of this type of coin. So that eliminates this possibility. We can't have a coin that is tossed and stands erect, after tossing. So a coin that has this possibility is not regarded to us or regarded by us as a fair coin. Okay, so a fair coin, this is not a fair coin. So in talking about a fair coin, this possibility of the coin standing erect is eliminated. What we are referring to is a coin that can only land on either of its base. Okay, so this is a fair coin and this is not. Now you also heard me say fair die, and I must clarify. A fair die is also a die that can land on any of its base but never on the vertex or the tip. Okay, so this is a fair die. We are referring to a die that can land on any of its base, okay, but never on the tip. So this is not a fair die. When discussing a fair die in probability, we eliminate this option. The option of the die after being tossed landing on any of its vertex or tip. So this option is eliminated. Hence, when we refer to a fair die, we are talking about a die that can land on any of its base. Okay, now that being said about random experiments and the terminologies you need to understand, let us go to the next thing. Now that we know what random experiments are, let's go to giving some general definitions to probability. Okay, so we will begin with this definition. Definition number one. In definition number one, we shall define probability. We shall define probability as the study of random experiments. So probability is the study of random experiments. Probability is the study of random experiments. Now, why is it the study of random experiments? It is because probability deals with experiments whose outcomes we cannot predict in advance. So, since probability deals with outcomes or with experiments whose outcomes you cannot predict in advance. You can define probability as the study of random experiments. Another definition you can give to probability, another general definition, is that probability is a measure, okay? Probability, as we will see subsequently, probability is a measure of the likelihood. Is a measure of the likelihood of occurrence of an event, okay? So, how likely is an event to occur or not occur is what we study in probability as an area, okay? So, probability is a measure of the likelihood of occurrence of an event, or you can define it simply as the study of random experiments. Of course, random experiments are experiments whose outcomes we cannot predict in advance. That being said, let us now go to a more concrete definition on probability. The definitions we just talked about, definition of probability in terms of random experiments and the definition of probability as the likelihood of occurrence of an event, those definitions can only do descriptions for us. They can only describe what probability is, but using them to solve problems, concrete problems in probability, may be very, very difficult. They can explain the problem, but they cannot solve the problem. So we need something more concrete. So that brings us to the empirical definition of probability. By empirical definition, we mean definitions on probability, or a definition on probability that stems from something practical, okay? Probably by experiment, okay? So empirical definition of probability is what we shall look at. So how do we define probability empirically, okay? How do we define probability empirically? Let's see. Now, empirically, probability may be defined as a ratio, okay? So what kind of ratio is probability defined as? Let's see. So empirically, probability may be defined as a ratio of the number of successes, okay? So take note of this word successes. So it can be defined as the ratio of the number of successes in several trials of a random experiment, okay? As the ratio of successes in several trials of a random experiment to the actual number of trials. Okay, so let's go over it again. Empirically, probability may be defined as a ratio of the number of successes in several trials of a random experiment to the actual number of trials. Now, let's see. For us to make this definition more concrete, let us consider a notation. So, the probability of an event, say E, is conventionally denoted by PRE. Okay, so if I want to describe the probability of an event, I will simply write PR standing for probability in bracket E standing for the event. So PR in bracket capital E would stand for the probability of an event conventionally. Okay, now if we note this as the notation, the conventional notation of probability, the probability of an event, then we can therefore define the empirical definition. We can therefore take the empirical definition concretely by doing this. So now that we know that we can represent the probability of an event as PRE, so let us rewrite that definition above in more concrete terms. So what did we say about the empirical definition? We said empirically, probability may be defined as a ratio of the number of successes in several trials of a random experiment to the actual number of trials. So all I'm going to do here is to say number of successes all over number of trials. And that will now become a more concrete way of describing the empirical definition. Okay? Now, I want you to take note of one thing. If in this definition called the empirical definition, you would notice that we are looking at two types of frequencies: the frequency of successes and the frequency of trials. So, in some way, you can actually redefine or call this empirical definition what is called relative frequency. Okay, so the relative frequency definition is also the empirical definition, or the empirical definition is also called the relative frequency definition. Why is it called the relative frequency definition? It is because we are taking the number of successes relative to the number of trials. So this definition can also be called the relative frequency definition. So I'll put here empirical definition may be called relative frequency definition. Relative frequency definition. Okay? So another name for the empirical definition is the relative frequency definition. And why is it the relative frequency definition? It is because we are taking the number of successes, that is the frequency of successes relative to the frequency of trials. Okay? So all you have to do to describe the probability of an event empirically is to take note of the number of successes in relation to the number of trials. Now take note of one thing. I must explain what successes mean. You've heard me use the word successes. So what does success mean in probability? Take note. A success is simply the expected outcome. The expected outcome. So let's say you were interested in carrying out the activity of tossing a coin. But before performing the tossing of that coin, you already desired a head to show up. Now, if after tossing the coin, a head actually shows up as expected, that head becomes a success. And the other side, which we will now call a tail, is not a success but a failure. So failure in probability, success in probability is not portray the conventional meaning of success or failure. Okay, so success in probability simply refers to the expected outcome. And again, let me give another example. Let's say you wanted to toss a die. Okay, you wanted to toss a die, and before tossing the die, your expectation was a 1 should show up. If on the first trial you toss the die, a 1 does not show up, any other thing that shows up aside a 1 is a failure. Now, what is a success is when a 1 as expected shows up. So a success is simply the expected outcome. However, what is not the expected outcome? What is not the expected outcome is called a failure. Okay? So what is not the expected outcome is called a failure, while what is called the expected outcome is a success. Now, that being said, let us take an example of using the empirical definition. So using the empirical definition is very simple, but one thing you must note about the empirical definition is that the empirical definition requires you to know the number of successes and the number of trials. So without knowing the number of successes and the number of trials, you cannot use the empirical definition to define probability. Okay, so noting that, let us take an example. So example, I'm going to call this example number 1. Example number 1. So let's see. In the experiment of tossing a fair coin 50 times. What is the probability? What is the probability that a head, in bracket success, will show up 20 times? So this kind of question can be answered using the relative frequency definition of probability. So all I have to do is note the number of successes and the number of trials. Okay, so I would simply say let E be the event of a head showing up. Then, if E represents the event of a head showing up, then the probability of E, that is the probability of a head showing up, becomes 20 over 50. And why is that so? It is because 20 is the number of successes, while 50 is the number of trials. And that reduces to 2 over 5. Remember, 2 over 5 becomes a measure of the likelihood of occurrence of a head. And that's what the definition we took earlier on was explaining. 2 over 5 becomes a measure of the likelihood of occurrence of a head. Okay, so all you have to take note of is that in using the empirical definition, you must know the total number of trials and you must know the number of successes. So in this case, it was 20 for success or successes, but our trials, our number of trials was 50. Let's take another example. So, example number 2. Example number 2. Okay? Now, let's assume that in a school of 500 students, 200 students were observed to be males, while 300 students were observed to be females. What is the probability? What is the probability of selecting a male? What is the probability of selecting a female? Okay, so if we wanted to solve this problem, of course, we will be needing the relative frequency definition. Why? It is simply because we know the number of successes and we know the number of trials. Okay, so what we shall consider in this case is event E1. Okay, so we say let E1 be the number of males, that's male students. Let E2 be the number of female students. So in this case, the probability of E1 becomes the number of let E1 be the event. Let E1 be the event of selecting a male student. Okay, so that's proper. Let E2 be the event of selecting a female student. Okay, so if we call E1 the event of selecting a male student and E2 the event of selecting a female student, then the probability of E1, that is the probability of selecting a male student, becomes the number of male students, all over the number of students in that school. Okay, so what does the number of male students become? The number of male students becomes our number of successes. In this case, since we are interested in selecting a male becomes a success, while selecting a female in this case will be a failure. So the number of successes in this case will be what we call the number of male students, and the number of trials will remain 500. Okay, so in this case, the probability of selecting a male student will be the number of male students, which is 200, all over the number of trials, which is 500, the number of students, and that will reduce again to 2 over 5. 2 over 5 becomes the measure of the likelihood of occurrence of a male student. Now, if we were interested in a female student, probability of selecting a female student, then that would be the probability of E2. In this case, the female student, selecting a female student becomes a success, while selecting a male student becomes a failure. And this would now be probability of E2 equals number of female students all over number of trials, and this would reduce to 300 over 500, and that reduces finally to 3 over 5. So 3 over 5 becomes a measure of the likelihood of occurrence of a female student. That being said, we will stop here in this video, and we will continue with our definition on probability using the set theoretic perspective. Okay, so in this video we have looked at the probability of an event from 2 general perspectives and the empirical perspective. In our next video on probability, where we shall also be answering the question, what is the probability of an event, we'll be looking at the probability of an event from what is called the set theoretic definition or set theoretic perspective. Thank you very much for watching this video. Until we meet again, please stay tuned.